ladies and gentlemen, Pathfinder's Master Guide. Welcome to Pathfinder Connect. Today we'll be looking at automobile mechanics honor. This is one of the honors that is found by the vocational skills section in the Pathfinder honor book manual. So without wasting much time, please like, share, subscribe to this channel, and don't forget to click the bell icon so that whenever we upload a new video, you'll be able to get it in time and watch it. So let's get into it. Automobile mechanics. Properly start an automobile. Question number 1. Properly start an automobile. Now, starting an automobile, there are two forms of cars. There is automatic transmission car, and then there is a manual transmission. So let's start with the automatic transmission. To start a vehicle with an automatic transmission, sit in the vehicle in the driver's seat and make sure the vehicle is in park. Insert the key in the ignition and turn it clockwise as far as it will go. The engine should crank. Do not depress the gas pedal. As soon as the engine starts, release the key. As soon as the engine starts, release the key. To turn it off, turn the key counterclockwise or anti-clockwise. All right. What about starting a manual transmission car? To start a vehicle with a manual transmission, sit in the driver's seat and push the clutch pedal all the way in with the left foot, okay? Then clutch pedal is the clutch pedal is the third one from the right. As people say, ABC, accelerator, brake, and clutch, ABC. And this is often the one furthest to the left. Although some vehicles have a parking brake to the left of the clutch. For example, Mercedes-Benz tend to have another pedal on the left, so they have 4 pedals. If they have 4 pedals, the furthest one is a parking brake. That is not the clutch. All right. Make sure the parking brake has been applied. Make sure the parking brake is applied. Inexperienced drivers should also shift the vehicle into neutral so that if the foot slips off the clutch after the engine starts, the car does not move. Question number 2. What are the importance of proper pressure and pressures and levels? Let's look at some of the pressures and the levels that you need to check in the car. The first one is the oil. Oil keeps the engine lubricated and reduces friction between the moving parts of the engine. Remember, the moving part of the engine is made of metals. So without the oil, they will start friction and it will wear out. Okay, says friction causes heat. So if there is insufficient oil pressure in the engine, it will quickly overheat. Running an engine without oil for any amount of time will damage it. And doing so for an extended period will destroy it. What about water? Water circulates through the engine to cool it. Running an engine too hot will damage it. Fuel, it is what makes the engine go. It's as simple as that. If the vehicle has insufficient fuel pressure, the fuel will not flow into the combustion chamber and at the proper rate. The battery. Battery provides energy to turn the engine's starter. If the battery voltage level is low, it may not be able to turn the starter. Now let's look at the types of engines that we have in a car. We have a 4-cycle engine, which says a 4-cycle engine is also named because it makes 4 strokes to generate power. These strokes are as follows. Stroke 1, 2, 3, and 4. So if you look at the diagram that is here, you can actually see the engine parts moving, and with each stroke something happens. With each stroke something happens. Intake stroke. During this stroke, the piston draws a mixture of fuel and air into the cylinder. The fuel and air enters through the intake valve, which opens during this stroke. Combustion stroke. Once the fuel and air have been drawn into the cylinder, the intake valve closes and the piston returns towards the engine's head. This compresses the fuel. Power stroke. When the piston reaches the top of the cylinder, the spark plugs fires, igniting the compressed fuel and air mixture and causing an explosion. This explosion causes the gases to expand, which powers the piston downwards again. This is where the engine power and noise comes from. Exhaust stroke. When the piston reaches the bottom of the cylinder, the exhaust valve opens, and as the piston returns to the top of the cylinder again, the exhaust gases are pushed out. When the cylinder reaches the top again, the 4 cycles are ready to repeat itself. Now, what about cars that have 2-stroke engines? How does the 2-stroke engine work? Let's look at the 2-stroke engine. As you see the video here, there's a 2-stroke engine. Okay. Power and exhaust stroke. In a 2-stroke engine, the spark plug fires every time the piston reaches the top of the cylinder. This is the beginning of the power and exhaust cycle. As in the 4-stroke engine, the spark plugs firing causes the compressed air and fuel mixture in the cylinder to explode, and the expanding gases drives the piston downwards. As the cylinder goes down, it compresses another air and fuel mixture inside the crankshaft, not inside the cylinder as in the 4-stroke engine. Intake and compression stroke. After the piston reach the bottom of the stroke, it begins traveling upwards again, compressing the air-fuel mixture that rushes into the cylinder from the crank during the previous stroke, and simultaneously drawing more air and fuel into the crankcase. By the time the piston reaches the top of the cylinder, the air and fuel mixture is very highly compressed, much more compressed than it was in the crankcase. It is at this point that the cylinder ticks, or the cycle that the intake valve closes and the spark plug fires. What is the difference between gasoline and diesel engines? What is the difference between gasoline and diesel engines? The fuel and air mixture is compressed to about 1/12 of its original volume in a diesel engine, in contrast to fuel and air mixture in the gasoline engine. Is compressed to about 1/8 of its original volume. The diesel engine must compress the mixture this tightly to generate enough heat to ignite the fuel and air mixture. The gasoline engine mixes the fuel and air before it reaches the combustion chamber. The diesel engine takes in only air through the intake ports. Fuel is put into the chamber or into the combustion chamber directly through the ignition system. The air and fuel then mix in the combustion chamber. the engine speed the engine speed and the power output of a diesel engine are controlled by the quantity of fuel admitted to the combustion chamber. The amount of air is constant. This contrasts with the gasoline engine, where the speed and power output are regulated by limiting the air entering the engine. Here we have a gasoline, what do you call this? This is the gasoline injector. That is the gasoline injector. And then this is the diesel injector. As you can see, the gasoline injector is very short because it's attached to the intake manifold. But the diesel injector is very long because it goes through the cylinder head. It goes through the cylinder head from the top of the engine. What is a carburetor system? The carburetor serves the following basic functions. The carburetor serves the following basic functions. Here is a diagram of a carburetor. All right. So on top you have air coming in. On top you have air coming in, and then you have choke valve which opens and closes to control the air that is coming in. And then you have the throttle body. You have the throttle body, and then you have the fuel system. Then you have the fuel system. You have the float valve, the float arm, the float itself, which actually tells the car how much fuel it has and how much fuel to put. And then this is the float chamber. All right. The carburetor mixes fuel and air into the correct proportion for the most efficient use by the engine. The carburetor also must constantly vary the mixture proportions to meet the engine's needs as its speeds and load requirements varies. The carburetor regulates engine speed and power output. The carburetor automates the fuel as it mixes it with the air. Okay, fuel injection system. Here is a diagram of a fuel injection system. So this is very simple. You have the fuel tank, which is mostly found if you are driving a saloon car, a family car, you find the fuel tank beneath the back seat. So there's a fuel tank, and you have what we call the fuel pump, which is here. Sometimes some cars have their fuel pump inside the tank. We will get into that as we go further. So if you have a fuel pump here, the fuel pump then pumps the fuel into what we call the common rail. In the common rail then disperses the fuel into the injectors. The ECM regulates how much fuel should come out of the injectors into the intake valve. And then here we have the pressure limiter. The pressure limiter, when it sees that there's a lot of fuel coming into the common rail, the pressure limiter takes the fuel, that is excess, back into the tank. Here we have a pressure sensor that actually put pressure on in the whole fuel system. Okay, the fuel injection system are an increasingly popular alternative to the carburetor for providing an air-fuel mixture. They inject under pressure and measured amount of fuel into the intake air. Usually as a point near the intake valve, fuel injection system provides the following advantage. Fuel delivery can be measured with extreme accuracy, giving the potential for improved fuel economy and performance. Because the fuel is injected at an intake port of each cylinder, fuel distribution will be much better, and fuel condensing is in the manifold will not be a problem. The fuel injector working under pressure can atomize the fuel much finer than the carburetor, resulting in improved fuel vaporization. Okay, here is a diagram of the inside of an engine. So at the base, we have what we call the crankshaft. The crankshaft sits at the bottom of the engine block, which houses your fuel pump, your oil pump, which I will show you a picture of as we go further. And then it houses the pistons. These are the pistons which are inside the cylinders. These are the pistons, and around the pistons, there's yellow lines you see here, what we call the piston rings. The piston rings also regulate the amount of oil that is going above or going around the pistons. All right. And then here you have your valves. You have the intake valves and the exhaust valves right here. And then you have your spark plugs. As you can see, 1, 2, 3, 4. That means this car is a 4-cylinder engine. On top of that, we have what we call the camshaft. These are the camshafts. So as you can see, there are 2 camshafts. Okay, there are 2 camshafts, and around the camshaft there is a chain or sometimes a belt that moves around these 2 and come around this one. As they move, as this one moves, so does this one's move, and depending on the cycle is moving, then it's either it's going to open one valve and close the other valve. Okay. Yes. So here you have it. Here is the camshaft. Here is the camshaft. Those yellow things you see here are what we call the rockers. Others call it tappers. We call the rockers. As the camshaft is moving, these parts here, they also move. And as they're moving, depending on which level is up or which level is down, it moves these rockers up and down. And which rocker goes down means valve is going down. Which rocker goes up means valve on that side is going down. This whole big dial you see here is what your starter is attached to. So when you turn your key, the starter spins and spins this whole big dial here. It spins this whole big dial, which also in turn moves the pistons up and down by moving the crank shaft. Okay, now here is how a V8 engine looks on the inside. The concept is still the same. It's just that this time you have 4 pistons on this side and 4 pistons on the other side. The same thing applies to a V6 engine. The difference is a V6 engine has 3 on this side and a 3 on that side. So depending on which engine you have, is either you have this like this as a straight 4, or it can be a 3-cylinder, or you have a V6 like this, or a V8. Okay, now here is a fuel pump that is inside. This is what we call the in-tank fuel pump. In-tank fuel pump that sits inside the tank. So normally if you drive a saloon car, or if you have a saloon car at home, a family saloon car at home, by removing the back seat where you actually sit, by removing that, you are going to find a cover that houses this, which is the in-tank pump. Its job is to pump the fuel from the tank to the front of the car. Some pickup trucks, diesel pickup trucks have this. Which are seated or are situated inside the engine bay. Its job is to pump is to pump the fuel all the way from the back to the front, all the way from the tank to the front. Sometimes you find some cars having two pumps. Some cars have two pumps. They have the high pressure pump and the low pressure pump. Mostly you find them in diesel pickup trucks. Okay, here we have the oil pump. This is the oil pump I was talking about. It's attached to the engine block, and this part here goes inside the oil pan. It goes inside the oil pan where the oil sits when the car is idle, where the car is turned off. As soon as you start the car, as the timing chain is also moving, it moves, it spins this. As it's spinning this, the pump is in here and it pumps and draws the oil from here and distributes it all over inside the engine. Here is your water pump. Here is your water pump. It's also attached to the engine. As soon as you start your car, the pump also starts spinning. The pump also starts spinning, pulling water to cool all the heating parts of the engine. Okay, what about battery? This is the battery we're talking about. From the beginning, you have to always check if your battery has enough power. Most normal saloon cars should start if your battery is producing anything from 8.5 volt upwards. If it's able to hold 8.5 volts, it should be able to start. But if you have a powerful car, sometimes it will not start. Some powerful cars won't start if the battery goes below 9.5 volts. So you have to know which car you have, so you buy your battery accordingly. Sometimes if you look on top of the battery or sometimes on the side here, depending on the brand, they write a number. You must check which number your car holds or your car uses to make sure that you have the correct number. Any number below that, your car might not start. Any number above that can set your car on fire. So please pay attention to those numbers. Here we have what you call the alternator. So the alternator's job is to take or to generate power to recharge the battery. The moment you start your car, the alternator should start spinning. There are belts attached to the alternator here. The same belt attached to your aircon pump and so on and so forth. It should start spinning and then generate electricity in here. The electricity that is generated is too high for the car, so then you have the power regulator. You have the power regulator, which is found at the back of the alternator, this side here, that takes whatever power the alternator is generating and convert it into 12 volts and send some inside the car for you to use on your radio, on your lighting, because other than that, then the car will be using the raw power from the battery, which will kill your battery in no time. So the alternator's job is to generate electricity. The regulator regulates it, sends some to the car for your normal use and sends some to recharge the battery. Okay. Standard transmission and automatic transmission. The transmission couples the engine to the drive shaft and has two main functions. Control direction of travel, forward or reverse. Provide the operator with a selection of gear ratios between engine and wheels so that the vehicle can operate at best efficiency under a variety of driving conditions and loads. In a vehicle with a standard transmission, the driver selects the desired gears manually. In a vehicle with an automatic transmission, the transmission makes the gear selection itself depending on throttle positioning, vehicle speed, and the position of the shift control level. In both cases, engine torque is transmitted to the wheels via a clutch. Automotive clutches depend on friction for their operation, where whether it be solid friction as in the conventional clutch found on a standard transmission, or fluid friction in and inertia as utilized in the fluid coupling and torque converter found in an automatic transmission. So here is a manual transmission and here is an automatic transmission. On the manual transmission, the moment you sit in the car, you look at the gear knob, you are going to see R, 1, 2, 3, 4, 5, or sometimes 6 is added to it. Nowadays, you have cars coming with 7 and 8. If you are in a truck, it can be even more. If you are in a truck, it can be even more. All right. In an automatic transmission, you are going to find letters, whether it's written up or it's on the side here, or it shows somewhere on the dashboard of the car. If you have these new technological cars, you find it like that. And you're going to find alphabets like P, which is for parking, which works almost the same as a parking brake. And then you have R for reverse, N for neutral, D for driving forward, and then 2, which sometimes is like a high-speed version of the drive, and then you have L, which is like a low-speed version of the drive. Rear-wheel drive and front-wheel drive. If you put a car on a hydraulic lift, raised all 4 wheels off the ground, turn on the engine and put it in gear, the rear wheels of rear-wheel drive vehicles would turn, while the front-wheel drive or the front wheels of a front-wheel drive would turn. In a 4-wheel drive vehicle, all 4 wheels would spin. The term simply indicates which wheels are connected to the engine via the transmission. Let's look at a front-wheel drive layout. So here you have the engine, you have the transmission or transaxle, and then you have the drive shaft. So is the engine, which is the red one. The pink one you see here is the torque converter, which takes the power from the engine, convert it into torque and send it to the transaxle, which is the gearbox, and then it takes that power through the drive shaft and send it to the wheels, the blue one. All right. And then when it comes to a rear-wheel drive, you have the engine, you have the torque converter, the transmission, and then you have the drive shaft, and then you have the torque, you have the final drive, where the car then takes all the power from here to spin the wheels at the back. If it's a front-wheel drive, if it's a 4-wheel drive, then you will have another system going here to send power into the front wheel as well. Okay. Drum brakes and disc brakes. Drum brakes and disc. So here is a diagram of a disc brake, and here is a diagram of a drum brake. These brakes basically has discs. There's the disc here, there's a disc, and then there is the disc pads, which actually brakes or has create a compression that whenever you press the brake pedal, fluid comes in there and compresses the parts together, which allows the car to stop. Then you have the drum brakes. Instead of compressing the parts together, it actually releases or pushes the parts apart, which these are the parts which in turn actually locks up its housing and allows the car to stop. Oil and air filter. Here is your typical oil filter that you find in your car, which is attached to the engine, and then If you have some BMWs, you are going to find this. There's a housing in which this sits, if mostly found in BMWs and Mercedes. And then most other cars have this type of oil filter. Okay. And then air filter, you can have a square air filter, box air filter, you can have a round one. Mostly if your car is a carburetor engine, this is the type of air filter that you find, the round one. And then this is what people use nowadays. They call it the cone. They call it the cone filter. Normally people remove the traditional box filter and then put this. These filters can also be used, especially this one, for the filtration of your air conditioning, the air that comes inside, what you call the cabin air. Oils. So we have the engine oil itself. Please, when it comes to engine oil, pay attention to this number here, 20W50. The 20W50 basically tells the viscosity or the thickness of your oil. If you put the wrong viscosity in your car might run, but not to efficiency. And then the same thing applies to transmission oil. Transmission oil. If you pick a transmission oil, please pay attention to what is written on it. Here you see an example of an automatic transmission on it. This picture here is an example of automatic transmission. And then they always write ATF. ATF, which basically says automatic transmission fluid. Don't take this fluid and put it in your manual transmission car. Please don't do that. Cooling system. Here is how the cooling system of a car works. So the cooling system of the car, basically you have the water tank. You have the water tank in which you put your water. You put your water in here. And then here is your radiator. So how it works is the water goes into the radiator. It goes and sits inside the radiator. And then your water pump, the water pump we spoke about before, sits or is attached to the engine right here. And as you turn the car, as you start the car, the pump starts spinning. And as the pump is spinning, it pulls water from the radiator and circulates it all over the engine, and then pumps it back up through this hose here, back into the radiator for it to cool down again. Here is what we call the cooling chamber of the radiator, and comes back into the engine again. Hot water that is inside the engine is pumped through the heat core. The heat core is what gives you heat into your car whenever you turn on the heater inside the car. All right, the heater is from here. Okay, and that is it. That is how the cooling system works. Changing a tire. Whenever you buy a car, please check inside the boot. If it's a second-hand car, make sure that you have the seller is giving you a spare tire, a jack, and a wheel spanner. A spare tire, a jack, and a wheel spanner. Jacks, please pay attention. Look carefully on your jack. The jack always have the maximum kilograms the jack can lift. If your car itself weighs 2 tons and your jack can only lift 1.5 ton, the jack will break the moment you try to use it. If your car is 2,000 kilogram and your jack can lift 2,500 kilogram, but you have loaded your car for it to now weigh 3,000 kilogram, please make sure that you offload the weight before you use the jack, else the jack will break. The wheel spanner, this wheel spanner is what you call the plus wheel spanner, or multi-level or multi-socket wheel spanner. So most of the time, if you have a wheel spanner like this, they are made to take different sizes of bolt and nut. That holds the wheel in place. So pay attention to which one you have and the bolt and nut size you have. If there is any question, please write it in the comment section and we will surely answer your questions. Thank you very much for being with us for this class. We will see you in the next class.